Okay, so I'm just going to walk you through a couple examples with drawing. You do have to follow the steps in order to draw the proper structure. It's just how it goes. You have to follow these series of kind of rules or steps. Okay, so we're going to do our first example with NBr3, which is nitrogen tribromide. The first step says identify the central atom with the highest bonding capacity, which means you just want to write out each atom, N and Br, write out how many valence electrons it has, and then how much space does it have to bond. So if you look here, N has 5 valence electrons and it has 3 spaces to bond, indicated by the circles, and Br has 7 valence electrons and only 1 space to bond. So in this case, N would be the central atom because it has more space to bond. Okay, so that's step 1. So if I were you, I'd be writing down these, even though the answer key is attached. You should write them out just for good practice. Or you could just do the practice questions at the end following along my example. Okay, so step 2, add up the total number of valence electrons. So you do need your periodic table to figure out how many valence electrons each atom has. So nitrogen is in family 5, so it has 5 valence electrons, and then there's 3 bromines, and each bromine has 7 valence electrons. So 5 plus 3 times 7 is 26 total valence. Okay, step 3, place bonding electrons between your atoms. So we're going to draw a rough sketch of what our molecule is going to look like. So I'm going to put N with 3 Brs around it, and then I'm going to attach them with a pair of bonding electrons, and I'm going to circle those because those represent bonding electrons. That's what holds them together. Okay? And then step 4 I've also included in this drawing. Step 4 says place remaining valence electrons as lone pairs on surrounding atoms, not the central atom. So we do not touch the central atom yet. So we're going to put all the lone pairs of valence electrons around the surrounding until we get to 8. So right now each Br has 2, 1, 2. So it needs 6 more to get to 8. So I'm going to put 6 more valence around each bromine. Okay, step 5, we're going to subtract the number of electrons used so far from the total number of valence. So your total number of valence we found out was 26 from step 2, and we are going to subtract how much is used up so far. So if we count here, there's 1, 2, 3, 4, 5, 6, 7, 8 right here, and then there's another 8 here and another 8 here. So 8 times 3 is 24. So 24 electrons have been used up. Okay, so we take 26 valence and we subtract 24 used, and you get 2 electrons. So that takes us to step 6. Place these electrons on the central atom in pairs. So we place these 2 electrons we just calculated on the central atom, which is shown right here, these 2 right here. Okay, and when you put the 2 electrons on the central atom, it pushes the other atoms down. Okay, so I'm just pushing the 3 Brs down. Okay, and then step 7, if the central atom does not have a full octet, you want to move valence electron pairs from surrounding atoms into a bonding position between those atoms. So in this case, we don't have to worry about that because the central atom is satisfied. So if you look, N, you want to count. It has 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 electrons, so it is satisfied. You do not need to borrow a pair of electrons here to move it to make a double bond. You do not need to do that. Okay, so we're gonna just finish off. Step 8 is just basically check your finished structure. Make sure each atom has a full octet, and you want to draw your structural formula by replacing the dots with sticks of your bonding pair. So every bonding pair is represented by a stick, and every stick means there's 2 electrons in there. Okay, so that's the final structure for NBr3. Okay, so this is a lot to take in. So that's why I'm gonna do another example, and you do have to practice this. Remember, you have to follow each step, okay? You can't cut shortcuts or else you might get the final structure incorrect. Okay, so next one is water, H2O. So you want to identify the central atom. In this case, it's O. and with the surrounding atoms, so there's 2 H's here. Okay, how did I figure that out? Because O has 6 electrons in its outer shell, so it has 2 spots to bond, and H only has 1 spot to bond. So this has more capacity. Step 2, add up the total number of valence. So oxygen has 6, and hydrogen has 1 each, so 2 times 1. So 6 plus 2 times 1 is 8 total valence. Step 3, place your bonding electrons between your atoms and do a rough sketch. So I'm going to do O and then the 2 H's beside it with a rough sketch of the bonding electrons between them. And then step 4, you want to place any remaining valence electrons as lone pairs around your surrounding atoms, not the central atom. In this case, it's not needed for hydrogen because hydrogen doesn't need any more than 2. So we can go ahead to step 5. Determine how many electrons are still available by subtracting your total valence minus used. So our total valence we've calculated up here is 8. Okay, and used, we have to count over here how much is used. 1, 2, 3, 4. So 4 are used. So you go 8, subtract 4, which is 4. So that means that's how many electrons we put on our central atom, which is step 6. Okay, so I put the 4 electrons on the central atom, and we're pretty much done because you just want to check to make sure the central atom is satisfied. 1, 2, 3, 4, 5, 6, 7, 8. It is satisfied. So we just replace our bonding pair with sticks and we're done. Okay, so I encourage you to practice using these steps, and the practice is down here, and I am going to create an assignment for this next week to submit through Google Classroom. So you want to practice these 3 going through the steps that I just went through. Okay, so there are some exceptions to the octet rule. Some atoms do not need a full octet to be satisfied, and you just have to recognize those. So boron, for example, it does not need 8 electrons. So BF3, it only has 6 electrons. So that's just an exception to the rule. And SF6, sulfur, can exceed the octet rule. It can take 12 electrons. And then these are other examples. Okay, you do not have to memorize this. I'm just letting you know there are exceptions. Okay, so try to practice these, and that's it for today. Take care. Bye, guys.